Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the module 2 of lecture 2 of module 5, technology of larval rearing. My name is Professor Gauravdhar Bhaumik. I am from the Department of Agriculture and Food Engineering from IIT Kharagpur. So in this particular lecture material, we will be discussing on the carp hatchery, site selection, desirable characteristics of carp hatchery sites, designing of a hatchery, salient features of different ponds, hatchery proper, and the components of modern hatchery proper. The site selection, when we go for the site selection of carp hatchery, the sites for which we normally we go for before finalizing our design and everything. So we need to finalize, we need to choose the property, right? We need to choose a particular site or particular farm at which you are going to design your farm or put your farm on. So when we do that, so what are the desirable characteristics that we need to follow? The first thing is the soil quality. You need to know that the soil quality in which your property is there, or I mean like when where you are going to farm, develop your farm, whether that soil quality of that farm has all the characteristics suitable for construction of a farm or not, that you need to take care of first. Okay. Availability of the good quality water, because the water is one of the one of the major component of it, and you need to provide the water for freshwater exchange, you need to provide the water for the farm cleaning and all, you need to provide the water for the all the manpower that they are there, so for their daily expenses and all. Okay. Other than that, we need water for post harvesting procedures and all. Okay. So it depends upon the design of the farm and what type of farm actually you are designing on. So the third thing is the area which should have with the adequate slope. Why we need a proper slope? Because see, when we design a farm, suppose you're designing a tight fed farm or a pump fed farm, or say like normal any kind of farm. So what will happen? So suppose you can have the water which is like incoming water from a particular source. It can be a surface water source, it can be a groundwater source, whatever it is. But if you don't maintain the inclination, if you don't have the proper the slope in your ground, so what will happen? You cannot drain the discharge water, you cannot drain the used water, right? So in order to design it properly and in order to reduce the burden in more amount of earthwork, what do I mean by earthwork? You have to cut the slope. If the slope is not available, then you have to cut the property in such a way so that there will be a proper slope, so that by means of gravity only the water will be on the side of the drainage canal, and you can just open the sluice gate and the water will be in the drainage canal, and through drainage canal you can easily discharge the used water. Or you can recirculate it back to the farm as well, depending upon the design and depending upon the type of what type of recirculated aquaculture system that you are designing. So these are the very important things. That's why we need a area with the adequate slope. It has to have easy accessibility to the market and necessary facilities, right? Because otherwise, suppose you are farming your target species and you have to transport it, say like 24-hour in a transportation medium. It can be anything, but most of these are perishable items. When we talk about the aquaculture products, almost all of them are perishable items. So 24-hour of transportation it may not sustain. So in that case, it can be a big of a issue. So that's why you have to have a market or necessary facilities like say like storage facilities, say like fridging facilities. Everything has to be near vicinity to the farm that you are designing. Easy availability of the raw material for operation. let's give you an example. Suppose you need a seed, right? You need to supply with the ample amount of fry. You need to supply with the ample amount of the construction materials. So all these things, all these raw materials has to be available in the near the place where you're actually designing your farm or you're actually producing your farming products. So other than that, the scope for integration of with agriculture, not only with agriculture but other purposes also we can do it, like we can go with the integration with the livestock also. So we call it integrated multi-tropic aquaculture, or we simply call it sometimes polycultures. We simply call it different type of there are different types of it, like integration of cultures. Okay, sometimes with the agriculture, sometimes with the livestock, sometimes within itself. Okay, so it depending upon the type and variant, we name it differently. So in case of agriculture, I'm giving an example like rice fish culture people do. So in that case, what happens, those the fish actually, like because of this combined culture procedure, you don't need to provide it with the nutrient, you need to provide it with the fertilizers, because the fish droppings and the excess the feed actually acts as a enhancing the quality of enhancing the nutrient availability of the for the plant. Whereas all the paste and all is normally like normally the fish and all these aquatic species, they actually feed they actually use it as a feed. So because of that the pest infestation can also be reduced. So there are like different other advantages as well. So I'm not going into details. In different lectures we have already discussed about it. So the next criteria for site selection of crop hatchery is the soil quality. As I already discussed, impervious to water, that's a very important thing, so that what will happen, if it is not impervious, the water will seep through gradually and you will lose a huge amount of water. It will go ultimately charge the groundwater. Okay, there are like lot of disadvantages of it. Major two is, first one, you lose the water, so you have to do a very frequent freshwater exchange. Second thing, the water contains a huge amount of waste or pollutants. That pollutants will leach. If it will leach along with the water through the groundwater, it will disrupt the groundwater quality. And once it will disrupt the groundwater quality, suppose you are using that same groundwater for irrigation purpose, for municipality purpose, or any other purposes, so it will definitely be deteriorate the subsequent operations. So that's why the soil quality is one of the major parameter here when we go for the site selection of carp hatchery. Okay, and the soil has to have a proper properties for rapid mineralization of the organic matter. It has to absorb the nutrient loosely bound and releases them slowly over a long period. And when we talk about the water quality, water with a high dissolved oxygen content is actually required at a desirable temperature. So depending upon the place of farming. So if you go for more minute details of the characteristics based on the quality, if you see in this table, it is like properly tabulated. The nature of the terrain, it has to be at least non-rocky, having at least 2.5 meter deep soil cover on its surface. Slope, a gentle slope has to be provided, as we already discussed. Physical quality, the soil fraction has to be around 90% of the whole soil 90%, with the whole soil stone and the gravel not exceeding more than 10%. Chemical quality, the pH of the soil has to be neutral, or maybe slightly basic, but better to be in a neutral region. Okay, total available nitrogen has to be more than 0.1%. Total available phosphorus has to be more than 1%, and carbon has to be more than 1%. Okay, and it should have to be responsive to the organic and inorganic fertilization. What does that mean? When you apply the fertilizers, organic or inorganic, whatever it may be, so it has to be responsive to that fertilization. Means that it has to work on there should be some microfauna or flora available in that soil vicinity, in that soil, so which will act on those fertilizers and which will help convert it into the reliable or the desirable nutrient available for the plant or target crop species that you are targeting in your farm. Okay, so this is and the same way, the same like way I can say about the different kind of carp production as well, because it's a pond, right? In the pond also, when you be designing, so there has to be a proper lining of a particular type of microfauna and flora on its surface. So for them also it is very important to have this chemical the properly chemically feasible soil available for the designing of the crop hatcheries. Okay, carp hatcheries. rate of seepage has to be as less than 1 meter per annum. The here 1 meter per annum, it says like, say it's like a meter cube per meter square. Okay, so I'm giving you one example. So if there is like seepage of 1 meter cube, 1 meter cube means 1000 liter, 1000 liter of water through a 1 square meter of land, area of land. Okay, so the seepage will be considered as 1 meter per annum. So like 1 meter cube of water is seeped through a 1 square meter of land mass, land area. So 1 cubic meter divided by 1 square meter, so it will be like 1 meter per annum. So that is the rate of seepage that we normally calculate in this unit. Okay. So the subsoil water table, it should not be far below the deepest pond bottom in driest summer months. So what will happen? Sometimes if in a very dry season, the subsoil water level should be ample enough, so it will let some amount of water available in the pond, available in your farm. Okay. Water supply, you have to have a dependable source of perennial water supply, sufficient to meet all the total requirement of the hatchery. I told you already, there are like different requirements. It has to fulfill all the requirements of hatchery. You have to have a certain source of water, dependable source of perennial water. It can be groundwater, it can be surface water. However, recently Government of India is pushing us to not to go for depending on the groundwater sources, rather try to go for recirculated aquaculture system or go for surface water bodies which can be utilized for further reuse. Okay. Chemical quality of water, as we discussed, the pH has to be neutral, temperature has to be between 10 to 30 degree, and should be responsive to the organic and inorganic fertilizations. And another important thing, it has to be the quality of water that you are supplying, it has to be free from all the other pollutants, especially the xenobiotic compounds. You know what is xenobiotic compound, right? Like different kind of chemicals which are persistent to the nature and which actually caused which actually come in contact with the nature by the anthropogenic activities only, like say our personal care products and all. So these compounds are very much hazardous, and even it's a very even it's in its nanogram stage or level. So that's why we need to make sure that it is free of all the xenobiotic compounds and all. It is not possible to go for how to say checking all each and every parameters, because there are like thousands of parameters available, thousands of chemicals available. So you just do a very standard test in a standard laboratory based on the Central Pollution Control Board or Namami Gange or different WHO guidelines. So depending upon the guidelines of the regulatory authority, you have to maintain the quality of the water. Okay. So when we design a hatchery, so what are the basic decisions that we need to make before going for designing a hatchery? First of all, what is the species of carp that you are choosing, that you are going to farm, right? Second thing is the size of the fry. Third is the quantity to be produced. So how do you know the quantity, right? Suppose I'm giving you one example. Okay. Suppose you have a say 10 hectare area. Okay, 10 hectare area. So it's a big, like huge farm that you have. So in a 10 hectare pond, 10 hectare farm, you're culturing certain type of carp, say like common carp. Okay. So when you're having a farm area of 10 hectare, you know that 10 hectare is the farm area, and you know the culture species is common carp. How do you know the number of fingerlings per hectare? That is y. You see the equation, A into y into b equal to c. Here A is the survival rate in percentage, B is the size of the harvesting, size at harvesting, and C is the yield at harvesting. Okay. How do you calculate these values? Okay. So when you go for the size of the harvesting, suppose you have you know that common carp, like say like it can go up to a size of 10 kg. Just giving you an example. Okay. So if it can go up to a size of 10 kg, and the yield of harvesting is like say like if you see the number of fingerlings per hectare can be which can be calculated by multiplying A into y into b, which is equal to c here. C is the yield at harvesting, A is the survival rate, and B is the size at harvesting. Okay. Just to give you some number here. Suppose the size at harvesting is like 1 kg and the survival rate is say like 80%. Okay. So if you have 100 number of fingerlings, 100 number of fingerlings at the end per hectare. So 100 multiplied by the size, which is like say 1 kg, multiply by the percentage survival rate, which is like 80%. So 100 into 1 into 0.8. How much it is the total the yield of harvesting? How much? 80, right? So 100 into 1 into 0.8. So it's like 80. So 80 kg per hectare is the yield at harvesting. Okay. So when 80 kg per hectare is the yield, like yield for yield at harvesting. So suppose you have a number of fingerlings. How you calculate the number of fingerlings? Total, you know, what is the area? Total area 10 hectare, right? And what is the yield at harvesting? It's like 80 kg per hectare. So and what is the number of fingerlings per hectare? 100. So 100 into 10. So total 1000 number of fingerlings are available for your area. Okay, that is your target. You need 1000 number of fingerlings for your production. It's just a very like it's just an example. Okay, don't take it seriously. The numbers are very not in real scale. Total say 100,000 number of fingerlings are available for for your 10 hectare area. 1000 number of fingerlings are available. Now, in order to get 1000 number of fingerlings at the end of your production, what are the number of post larvae that you need? How you calculate that? We go like reverse engineering process. Why we go for this reverse calculation process or reverse engineering process? I am giving an example. Suppose number of fry. So you know the total number of fingerlings you need 1000. Okay, that's for sure. So now you know that the number of fry. How you calculate the number of fry? In general, in standard, we consider that 80% of survival rate from fry to fingerling stage. Okay. So if fry to fingerling stage is 80% of survival rate, so total number of fingerlings is 1000 divided by survival rate, which is 0.8. So it will become 1250, right? So 1250 is the number of fry that is required. If we have 1250 number of fry, it will end up having 1000 number of fingerlings. So that's the general calculation procedure. Okay. Now, so to have a 1250 number of fry, what is the number of post larva that you require? From post larva to fry, it's a very early stage of their development. There is a very less chance of survival. So it can, for the sake of calculation, we say like 50% survival rate. If 50% survival rate from post larva to fry, so number of fry now we know 1250, and percentage of survival rate is 50. So if you divide it by 1250 divided by 0.5, so total number of post larvae will be 2500. You understand my point? So total number of post larvae that you need to supply to your you need to have your farm is 2500. If you have a post larval stage of 2500 amount of carp in your hand, so at the end you will get the final production stage, you will get like at least fingerling stage you will get around 1000 fingerlings, which then can be transferred to the grow out pond. You understand the calculation here, how we go for when we design a hatchery, how we calculate the quantity of it. Okay. So let's move ahead with. So what are the other salient features of different ponds? Okay. So like we know that we have a broodstock pond, we have nursery pond, we have rearing pond. Okay. So there are like different, like maybe there is some spawning grounds or spawning ponds are also there, depending upon the type of farm, or like sometimes they also put it like this. So anyway, so nursery pond, it has to be, what are the criteria that should be there for the nursery pond? It should be drainable, small size, like around not more than 0.1 hectare, depth should be 0.5 to 1.2 meter, and pond bottom has to have a gently slope towards the outlet point. Okay, outlet plane. The rectangular shape or the convenient width will be like convenient, because rectangular shape is convenient, plus the width has to be convenient enough for netting operation. A sump at the outlet for collection of fry has to be there. Rearing pond, in case of rearing pond, the drainable ponds this are larger than the nursery actually, because the size of the fish is much higher than the nursery pond here. The depth is around 0.8 to up to 2 meter. Okay. Pond bottom same, gently sloping towards the outlet, and rectangular shape and convenient width for netting operations, and a sump at the outlet for collection of fry and fingerlings. So, brood fish pond is the pond where we culture the brood stocks, right. So, like drainable or of a rectangular shape. Okay. In general, brood stock ponds are actually we are expecting to have this design. It should have provision of flushing with cold water at 25 to 28 degrees Celsius. Convenient source like artesian, open or tube, or underground spring water has to be there. Okay. A width of around 20 to 30 meter facilitates the netting operations, and depth are in general 1 to 2.5 meter. Okay. So, these are all the design criteria that you have to maintain when you will be designing a different kind of ponds inside your hatchery. So, when we design a hatchery proper, so that is the most vital component of modern fish farms. So, when we design a hatchery proper, so essential components of a modern hatchery proper are anti-tanks or the storage tank, breeding tanks or the wire tanks, incubators or the hatching jars, and the larval rearing tanks. Okay. So, these 4 are the very important one. First one, the storage tank, where we store the ripe breeders or say like brood stocks or like parents, okay, prior to the hypophysation. We know hypophysation, right, like we artificial propagation methods we sometimes provide. Then say like around 200 to 450 square meter of area with a 1 to 1.5 meter depth can hold at least 25 to 50 sets of brood fish. So, this is the first storage tank that we talk about, or brood stock pond sometimes we talk about in earlier slides we discussed. What are the diverse function of anti-tanks? It holds the breeders before the hypophysation. It has the capability to hold and rear the fry even prior to sale. You can use the same tank for holding fingerlings prior to sale, and also it can serve as a treatment tank for diseased or infected fry, fingerlings or brood fish, which sometimes called quarantine tank as well. Okay. It can provide additional space for operating jar or funnel incubators to collect the waste and all. Okay. Breeding tanks where it requires a continuous supply of clean and well oxygenated water at of optimum temperature. The slope for easy drainage and standpipe for maintaining the water level. Rectangular in shape, it's better. It can be of various shape, 2.5 by 1.5 by 1, 7.5 by 2.5 by 1, like it depends upon the type of the design and the expectations from the farm that you have. So, in general, if you talk about the circular breeding tank, they are like they provide, if you see the bottom picture. So, if you see the flow is given from a angle wise, because of that there is a continuous flow maintained in the water body, at least on its surface and up to a certain level, and as because height is not much. So, this circulation is maintained. So, continuous flow, it gives a river like environment, and why it is given. The fingerlings or the the breeding tanks, they have the tendency, because they normally grow in a natural environment, right, in the rivers. In the rivers, what they do, they go to the upstream region, sometimes they go to the downstream region depending upon the type of carp. So, they go and they go lay eggs there, right. So, they, in order to mimic the natural the process, we provide this kind of structure. So, it has also this circular breeding tank, so with the provision of river like environment with a continuous flow. So, depending upon this breeding carp, whatever the breeder it is, so they will go against the upstream or they go towards the upstream and try to breed at its level. So, at least up to a certain extent to mimic the natural environment. Uniform distribution of oxygenated water is possible because of the continuous flow, and centrally located outlet with a screen protects the egg better from getting washed away. Okay. So, in the middle, if you see, there is a screen there. So, it functions like a rearing, hatching and breeding, and also it can combine all three operations in this kind of tanks. What are the drawbacks? It has a very high water consumption, but nowadays scientists have found out the solutions for that as well. They know that when the water consumption is very high, what we do, we simply provide it with a treatment unit. a small treatment unit it can provide. It can be biological treatment unit, it can be like sand filter based something, like it's a like physical treatment unit, it can be some UV or ozone, like where it will get rid of all the biological pathogens or microorganisms, so unwanted microorganisms. By means of this we can clean the water, we can put it back to the tank again. So by this way you can troubleshoot this drawback, this like higher water consumption. One major problem is repairing the central outlet, because sometimes it's huge, and in order to repair the central outlet you have to completely drain the whole tank, and then only you can utilize it for further purpose. So that's one of the nuisance for this kind of structure, this kind of the how to say the design. Incubators or the hatching jars, the inlet of water below or above, and outlet has to be above of it. So if you see the structure how it looks like, the incubators, in general the hatching jars, where we normally the hatching is take place, the design is given in the right side. If you see the inlet pipe, valve, water supply line, the jar bottom, pipe, and the plastic jar, how it looks like, and in general the shape of it, like the cylindrical shape one is shown here. The material is normally the clear glass or the plastic, or sometimes the baked clay. I'll show the baked clay how it looks like in the next slide. And the volume of one hatching jar can be 1 liter to up to 200 liter. Each jar of like 1 liter of size can hold up to 1 lakh of or 100,000 water hardened swollen carp eggs. Okay. This is the earthen clay the incubator that I wanted to show you how it looks like. It's actually very cheap and easily replaceable and porous and cool, and it used to be there in earlier day. People used to use this kind of hatchery, this kind of incubators and all. So operational procedures of a hatchery proper: first you disinfect the whole anti tank before stocking the brood fish. Proper net cover has to be provided, so that there is a less chances of any unwanted particles or the droppings, or say like predators can catch the brood fish, because they are very much slow than their normal maturation stage. Clean oxygenated water, continuous supply of clean oxygenated water with the dissolved oxygen concentration more than 4 to 5 if it's possible, at 27 degrees Celsius, to be used with a flow rate of around 30 to 45 liter per minute to mimic the natural river environment. After hatching, the flow rate increased to 45 to 50 liter per minute, and 6 to 8 millimeter meshed nylon net is used to collect the discarded eggshells, to just so that it will not get sedimented and not be in touch with any a sharp object or any sharp. For them it's sharp object, and it will we cannot use it anymore. So we just, in order to increase the efficiency of egg collection, we increase the flow rate and all. So then the last thing comes as the larval rearing tanks in case of this hatchery proper. The eggs have to be transferred to the breeding tank, to the hatching tank, and later the hatchlings have to be transferred to the larval rearing tank before packing for transport or stocking into nurseries for further rearing into fry. Okay, depending upon some hatcheries, their only purpose is to transfer the larva to different other hatcheries and all. Okay. So, and some actually want to go ahead with their own farm only. So, in that case it will transfer it to the nurseries for further rearing into the fry. When the fry stage has been reached and the young fish begin to require the exogenous food, they are then taken out of the hatchery and we put it in the rearing pond, which is a proper larval rearing pond. Okay. So, where they go for up to fingerling stage. Suitable basins for larval rearing have to be provided. In general, a set of around 1.5 to 1.2 to 1.2 to 1.2 meter cube of basin have to be made, and the hatchlings are nursed therein for further development and growth in this hatcheries and all. So, whatever we have discussed about the carp hatchery, so we can conclude that before designing, whatever I have discussed is the very basic things. I am not going into the engineering details much, because I know if we go for the engineering details, it will take a huge amount of time, and also it requires a proper classroom discussion. Not only classroom, but even online also is possible, but it requires a huge amount of time. So if you want to know more about it, you can contact me, or you can maybe in later in other the course will discuss more in details about the design of each and every individual part of hatcheries. Design is carried out on the basis of species, number of fry, etc., and design hatchery proper is one of the most vital component of modern fish farm. So these are the things that we have discussed, and what are the takeaway message? Proper site selection is very important. Designing of components based on the proper site selection criteria, based on the type of species, based on the type of environment or the place that your culture having your farm depends. Proper management of hatchery operation is very important when you go for any kind of carp. It can be common carp, it can be silver carp, anything. Okay, so it can go a huge way in successful production of fish seed for using grow out ponds in different other purposes. So anyway, so in the coming lecture we will be discussing about the prawns and the shrimp hatchery design, unless the carp one that we discussed today. This is the reference from which we have taken some informations, and we'll see in the next class. Okay, thank you so much.